Does the universe need you to exist? What if the universe isn't just out there? What if it's waiting for you to look at it to become real? You probably think of reality as a fixed stage where we're just the actors, solid, unchanging. But what if the stage itself is just a draft, and it needs an actor, you, to read it into existence? This isn't just some late-night dorm room philosophy. It's a radical idea from one of the 20th century's sharpest minds, John Archibald Wheeler. This is a guy who worked with Einstein, a guy who gave us the names black hole and wormhole, and who wasn't afraid to ask the biggest questions imaginable. He proposed that the universe waits for an observer to become real, which would turn you from a spectator into a co-creator of cosmic history. To get our heads around how that's even possible, we first have to face a very, very strange fact about the world. A fact that breaks almost everything we think we know. Section 1. The foundational mystery. At the center of it all is an experiment so simple, yet so deeply weird, it's been messing with scientists' heads for a century. The double-slit experiment. Picture firing a tiny particle, like an electron, at a wall with two slits in it. Behind the wall, a screen shows where they land. Now, if you close one slit, the electrons act like you'd expect, like little bullets. They go through the open slit and hit the screen in a single band. Easy. But open both slits, and something completely bonkers happens. The electrons, these tiny solid particles, suddenly start acting like waves. Instead of two bands, they form an interference pattern, a series of stripes. This pattern only happens if each electron somehow goes through both slits at the same time and interferes with itself, like ripples in a pond. Welcome to the quantum world, where particles exist in a fuzzy cloud of possibilities, a state called superposition. But this is where it gets really weird. The instant you put a detector at the slits to see which one the electron actually goes through, the wave pattern vanishes. Poof, gone. You just get two bands, as if you were shooting bullets the whole time. It's almost as if the particle knows you're watching. The act of observing it forces it to quit messing around and pick a single, definite reality. This is the observer effect. And it's not just that our tools are clumsy, it happens no matter how gently we look. The very nature of reality seems to change based on whether or not we're paying attention. This shatters the old-school idea of a fixed universe that just exists without us. It begs the question, if observation changes reality, then who or what is doing the observing? Section 2. The Maverick Thinker. This is where John Wheeler strolls in. Wheeler wasn't happy with the standard answers. He thought physicists weren't taking the observer effect to its logical and frankly terrifying conclusion. He didn't just think observation disturbs reality. He proposed something way more wild, that observation is an act of creation. Wheeler famously said, "No phenomenon is a real phenomenon until it is an observed phenomenon." In his mind, before anyone or anything makes an observation, the universe is just a smoky dragon of potential. It has no clear shape, no set history. It's just a fog of pure possibility. Our observation is what forces it to become concrete and take a definite form. He called this the participatory universe. That name alone is a revolution. It changes our whole relationship with the cosmos. We aren't just living in the universe, we are participants. The universe and the observer are locked in a creative dance. And to show just how deep this dance goes and how it messes with our idea of time, Wheeler cooked up a thought experiment that's even stranger than the last. Section 3. the delayed choice experiment. Wheeler asks us to imagine the double-slit experiment on a cosmic scale. Think of light from a quasar, a blazing galaxy billions of light years away. That light has been traveling for eons. On its way to us, it passes a huge galaxy that acts like a gravitational lens, bending the light so it can take two different paths to get to Earth, one around the left side, one around the right. Now, here on Earth, billions of years after the light started its trip, we have a choice. Option 1. We can point a telescope to see which path the photon took. If we do, we find it acted like a particle and chose a single path, left or right. Option 2. We can put a screen where the two paths meet. If we do that, we get an interference pattern, proving the photon acted like a wave and traveled both paths at once. Here's the mind-bending part. We make our choice, billions of years after. The photon passed the galaxy, yet our decision today seems to define the photon's ancient past. If we decide to check its path, it will have traveled as a particle. If we look for the wave pattern, it will have traveled as a wave. This is Wheeler's delayed choice experiment, and it's been confirmed in labs. Our observation in the present seems to lock in a past that was, until this very moment, undefined. The past isn't set in stone. It's just as open to possibility as the future, only collapsing into a solid story when it's observed. Wheeler had a great analogy for this. He said it's like a game of 20 questions, but with a twist. The person answering doesn't have an object in mind. They just make sure every yes or no is consistent with their previous answers. Each question you ask narrows down the possibilities until, at the end, an object emerges. The object didn't exist at the start. It was created by the questions. Wheeler suggested the universe does the same thing. Reality is the set of answers to the questions we ask it through our observations. Section 4. The so what? It from bit double star. So what does this mean for us? This is where Wheeler drops his most famous and profound line, it from bit. That little phrase is massive. It is every physical thing, every particle, planet, and galaxy. Bit is a unit of information, a single yes or no answer. Wheeler's radical proposal was that the physical world, the it, springs from the non-physical world of information, the bit. In this view, reality isn't made of matter and energy at its core. It's made of information. Every time an observation happens, a bit of information is registered, helping to define what's real. When a detector clicks, that's a bit. When you measure an electron's spin, that's another bit. These acts of gathering information are what carve reality out of the marble of quantum uncertainty. This led Wheeler to his participatory anthropic principle, PAP. This wasn't like other theories that just said the universe's laws seem lucky for life to exist. Wheeler's version was bolder. It suggests that observers aren't just lucky, they are required. The universe, in a way, has to create observers. Without participants to ask questions and register bits, it would stay a cosmic ghost, a universe of pure potential that never becomes real. He saw it as a giant, self-creating loop. The universe starts, it evolves, it creates observers like us. We then look back at the cosmos, observing light from the beginning of time. In doing so, we provide the observation that gives that history its reality. The universe creates observers, and observers, in turn, give the universe a tangible existence. This idea that we are not just specks of dust, but active participants in creating cosmic history, is one of the most stunning shifts in perspective science has ever offered. If being a co-creator of reality fires you up, let us know in the comments. And subscribe for more journeys into the deep connections between mind and matter. If we are participants, what kind of world do we want to help create? Section 5. Consciousness and misconceptions. Okay, a quick reality check. This isn't a suggestion that you can just wish for a new car and have it appear in the driveway. Wheeler's idea is often misinterpreted to mean that human consciousness, by itself, creates reality. In quantum mechanics, an observer or a measurement doesn't have to be a person. Any interaction that collapses the quantum fuzziness, like a particle hitting a detector, counts as an observation. A rock can't observe, but a detector definitely can. However, the line gets blurry, and even Wheeler wondered about the special role of consciousness. A detector can register a bit, but it can't build a theory or ask new questions. We aren't just participants. We are meaning-making participants. We are the part of the universe that is aware of itself, that develops laws of physics to understand the whole process. This opens the door to a universe where mind and matter aren't two different things, but are deeply and fundamentally tangled together. Conclusion. So does the universe need you to exist? In a sense, yes. According to Wheeler's participatory universe, it doesn't need you specifically, but it absolutely needs observers. It needs participants to turn its infinite possibilities into a single, definite reality. From the strangeness of the double-slit experiment to the time-bending puzzle of the delayed choice experiment, we're led to a staggering thought. We aren't insignificant specks in a cold, empty void. We are the universe's way of becoming real. We are the storytellers giving a voice to a cosmic story that was, until we got here, unwritten. The universe has been telling a story for billions of years, but the final draft isn't done. Every question we ask, every observation we make, adds a new word to the page. The story is still unfolding, and you're holding the pen. So what will you write next?